So, hello everybody, and welcome to another one of our Kitronik Tech Talks. Today you've got myself, Kevin, and one of our usual helpers, Alasdair. Alasdair's one of our designers, so he's going to take you through the Halo HD today, which is one of our products that's been around for a little while, but it's a popular product and it's very visual, so hopefully it'll be quite good to see on the videos. So, as ever, we've got Mark answering questions. So if anyone wants to pop some questions on YouTube, please do that. We'll pick those up and we'll do our very best to answer those as we go. And this video is also going to be available on YouTube afterwards. So if you want to watch back, then you can do that. That's fine. Is my video still out sync here? Yes. Yeah. Terrible. Sorry, give me a second, everyone. I'm going to restart that. Is that better?
That's better. That's better.
Right. Yeah. Weird. Know what's going on. Okay. So we'll start off by explaining what the product is. Give you a bit of an overview as to what it does. Do you want to do that?
Yeah, brilliant. I might just switch camera, people, so you can just see what I'm talking about. Just so you can see the Halo HD.
Get you a bit bigger.
Here we go. So this is the Halo HD. It's one of our BBC microbit boards. The big feature is it's got lots of LEDs, these RGB controllable zip LEDs around the outside. There's a whole bunch of other features on board. Microbit nicely slots in here. It's got a battery pack included on the back for three AA batteries. So it's all in one, doesn't need anything extra with it. Once you've had those batteries, you're good to go. Shall I go through the main features on the board at this point, Kevin?
Yeah, that's great.
Great, yeah. So it's, as I say, it's got 60 fully controllable RGB LEDs. It's got a nice slot-in edge connector here for easy access for the microbit in and out. We've got a power switch. We've got a little buzzer, a little sounder. Now, I know for people who've got a V2 microbit, that's already got a speaker on board, but this is fully compatible with V1 and V2 microbit, so you get all those features. It's also got a microphone down here for audio input as well. And here in the center, it's got a real-time clock chip, which will certainly make sense a bit later. We do some demonstrations. So that adds a really nice feature for making clocks with this board. If I flip it over again, you can see it because it's got that integrated battery cage. There's no need for extra wires to plug in. There's no need to try and add a trailing battery pack to it. You can keep it and it's portable. Nice to hold, and there you go. Nice and simple, but a really good product, and we'll be showcasing some of those extra features a little bit later on.
Great.
Switch back to my face.
Yeah, let's get back to gallery view. Yeah, so what I'll do is I'll show people what these actually cost to buy. So people can see this here. So the unit's about just over £20, coming down to about £18 in volume. We do actually also sell this in a few other sort of varieties, don't we? We're going to cover those later on, but this is sort of the main board, just the board on its own. But yeah, I mean, it's quite a nice picture, this, isn't it? Because it shows you the actual LEDs lit up properly. What would you say the use of this is, Alasdair? Is it more of a classroom product or a hobbyist product?
I think it nicely fits into both categories. I think with all the features on it, you could do some really nice little home projects with clocks or lamps, other things like that. But in the classroom, again, because it's got quite a lot of features going on, there's a good range of lessons it can fit into. And actually, one of the other products it fits into, which we'll talk about a bit later, is completely designed for classroom use with lessons across a number of subjects and a number of age groups as well.
Yeah, fits
in well with both categories.
And like you say, it's such a simple product to use. It's portable. The batteries are included, and the fact the microbit slides in is super simple. So I think you've covered all the features on there. I mean, is it worth showing the original Halo that we've sold?
I think that's a bigger thing to do, because you can see that some of you might know already that a number of years ago we had the original Halo product with these color changing LEDs. and you can see them next to each other here. So this is the original. This is, again, you see the new one already. And I guess you can probably see quite obviously immediately these are the much bigger zip LEDs, the color changing programmable RGB LEDs. There's only 24 of them on here, whereas we've got 60 on this side, but they've got the same nice brightness, same colors, so the same functionality there of programming. Also, on the original, it was a bolt-on connector, so you used bolts to put your microbit in place, whereas slotting into the edge connector is much easier for taking in and out for programming and for.
And part of the reason we use bolts is that when we designed that board, you couldn't actually get these surface mount microbit connectors. It's quite a large, bulkier through-hole connector at the time.
Yes, so it's been nice to see how things have adapted and changed from microbit as well in the intervening years. And obviously, I talked about already. There's things like the extra, the buzzer, the microphone, and the real-time clock chip. Whereas the original Halo was just the LEDs that went with it. So
and it didn't have the batteries, did it either? So you'd have to sort of.
No, there was just you had to wire in a connector to then plug in an external battery cage or a wired-in power source. So hopefully you can see it's a nice improvement with the new one. That makes it a really great product.
And we specifically wanted to go to those smaller LEDs, didn't we? So that we could get 60 on to act like a. Well, I mean, one of the things I'm sure you'll talk about is clocks, but
yes,
with 60 you can cover each minute in an hour.
Yeah. We had done clock things before with this Halo, but it really didn't work quite so nicely as having the right number for the right number of seconds and minutes in an hour.
Yeah, fantastic. Okay, so we'll quickly run over the other products that are based on them. Again, what I'll do is I'll share those. So hopefully you can see this. So this is the board on its own, but we do also have an alarm clock kit based on the board. It is a slight variation on the board, isn't it, though, just specifically to the requirements of a clock. I'm not sure it's clear on here.
If you go to the fifth one down, I think.
Yeah.
There we go. So you can see that rather than the battery cage and the one I've just shown you in person, to make it better for a clock that you want sitting by your bed for a long time, it's got a DC power jack that you can wire into a USB where you might charge your phone. And it's also got a little backup battery there. You can see the coin cell. So that if you did lose power, just like an alarm clock you might have by your bed anyway, you won't lose the time. You won't lose your settings of your alarms you might have in there. I'm going to show a little bit later just at one of the tutorials from that. But yes, that's the only difference really. And it comes with some little perspex bits for creating a stand.
Yeah, so that's quite a nice little product. And then we have the sort of much larger classroom ready pack, sort of curriculum ready resources here, aren't they?
Yeah, so this is it's called the Visual Computing Pack, which is it's all about data visualization, using the lights as a way of visualizing data. We've got subjects for physics, for geography, for DT. So making a mood light or creating like a sound meter. We've even gone in for a little earthquake shake meter for geography to see those things.
That's that board, isn't it, there that creates that?
Combine those things together. See, it's a nice big pack for the classroom with lots of written teacher resources, the lesson plans, PowerPoints, that sort of thing.
Yeah, and they'll come on like a memory stick, don't they, for the teacher to use.
Yeah, there's even some fun things like that. You can see the kaleidoscope there in the tried and tested section. I would show you it working here, but it's a bit tricky on a camera. That's like a fun extra thing you can do on an enrichment or an open day to showcase how some fun cardboard builds can come together to form an educational exercise as well.
But if people want to see that, there's videos and explanations on that page there, so it's available.
Definitely, that's good web page telling you everything that's on the drive, everything that it covers. There's a good number of resources there. Yeah,
so the main products, but it's also available in these other packs. Let's stop that. Look at the table wobble. Okay, so I think you've got some examples you're going to demo for us, aren't you?
Yes, I thought it would be good to just show how we program this and the environment. What I'll be using today is the MakeCode environment for microbit. So I'm just going to share my screen right now.
So one of the questions we've had so far, just before we move on, is, there's some little pads that are near the edge connector on the board. People asking what they're for.
Oh, brilliant! Yeah, before I share, then I'll just switch back to the camera and talk a little bit, just so you can see what if some other people didn't notice those. So I think they're referring to these ones here and here, I'm guessing. So what we've done there is we've broken out a ground pad, a battery voltage, and one of the signal pins on the microbit. So we've got pin 2 on this side and pin 1 here. So those are the bigger pads here and here. We've broken those signals out. And we've actually set it so it's like a servo, standard servo connector header. Some of the hobby servos that we sell. So if you attached some pin header there, you could drive servos from this, or because we haven't put those headers in, you could wire in something that you wanted as either an input or an output, perhaps a sensor, or just some extra things you wanted to connect to or control.
Okay, so if you wanted like a large button to turn your alarm clock off, you could wire one in.
Wire that in there. Yeah, that's a really nice extra feature. You could build your own case for it and then include that. And we just wanted to add that extra functionality for users who might want to go a bit further and are more confident with soldering and that sort of thing.
Great.
Yeah, I'll switch back again now. Yeah, I'm going to be opening up the MakeCode programming environment. So this is probably for anyone who's starting out with microbit, or even those further on, this is the place you'll probably come to program in your exciting programs for the microbit. And this uses either a blocks-based language, or you can switch to a typed versions for JavaScript or Python. But when you first come here to makecode.microbit.org, you'll have the opportunity to start a new project. Or if you're really new to microbit, there are these great starting tutorials that Microsoft have provided for just getting to know your microbit and how to program it and what sort of features there are there. But what I'm going to do is I'm going to start a new project, and it's going to be really simple. I'm just going to call it Rainbow, and you'll see why in a minute. So you type in your name there and you click create. And what it'll do then is take us away from that home page here onto the actual programming area. So we've got up here a little simulator of the microbit. So some of the stuff like displaying text or pushing buttons, you can just check that's working there if you're just programming your microbit. Here we've got the categories for different kinds of blocks. So if I open one of those, you can see there's these here, and you can just simply drag those in into your main programming area, which is here. For using the Halo HD, we've actually made it it's more simple for us to do, taking away some of the extra work that would be perhaps a bit too complicated for users. We've created our own little package, so I'll just move my out of the way. So if you go to the cog up in the top right and click extensions, there's then the chance to search for extra ones. So I'll search Kitronik, press enter there, and we've got a whole range of extensions that we've created for our products to make them really accessible and good to use straight away. But we want this one here, Kitronik Halo HD. So you just click on that, and that will bring in a new category to our list here on the left. You can see Halo HD. So open that. We've got sections for those zip LEDs. That's those 60 RGB LEDs around the outside, some microphone blocks, and some blocks for the clock. Right now, I'm just going to go into the zip LED section. What I want to do is I want to set up those lights around the outside. So we're telling it that at the start of the program, we want to set up the Halo to have 60 LEDs. And then I'm going to choose this other block here called Show Rainbow. Now the 1 to 360 in that is just saying you want the color range to be the full one. You could set there to only show the reds and the oranges, but I want to show the full color spectrum here. And to make it do some more interesting things, I'm just going to put in the forever loop. So that means code that will run forever without stopping unless you turn off the power. I want to rotate those LEDs. So the color settings will move from LED 1 to LED 2 and etc. going all the way around. So I'll rotate it by 1, and then I'm going to make those changes visible. And it's really simple. You go down here, and click save. And then I'll just plug in my microbit with a, so I've got, you probably can't see because it's very small, but I've got a USB, simple micro USB to USB cable that I've plugged into the computer, plugged in my microbit, and it comes up here just like a USB drive you might use. And if I grab the downloaded program here, and it's going to disappear briefly, but I'll just bring it back. I drag it over here, I drop. You'll see you've got this progress bar up here telling you you're downloading your code to the microbit.
Not sure I can see that.
Oh, sorry. I might just be showing them on screen. Sorry. So I've just dragged and dropped. Let me share my. I'll stop the share and switch again. Thanks, Kevin, for letting me know.
That's the kind of thing I do.
So I've got. Yeah. Can you see now? I've got this USB drive there. So I'll take my code from here, which I downloaded. Just simply move it across to the microbit area. Then you've got a progress bar that tells you you're downloading your code. And once that's complete, you're able to unplug your microbit, and then I'll stop sharing and just switch back to the overhead camera.
You can actually pair the microbit as well, can't you? So it just downloads automatically onto it.
You can do.
Yeah.
So that's, you can go up, you can go into here and click connect device.
Yeah.
Which is a good feature when it's working. So I'll stop sharing just for now and switch camera again so you can see what I'm talking about. So I've got my microbit here. It's currently connected to the USB, but I can just pull that out, plug it into my Halo there, and just flick the on switch. And then there are the LEDs have come on. So that's that rainbow was displayed stationary at the start, but then forever it's going to loop round and round. And you can just see really nicely all those colors because we've got those much smaller LEDs. They're nicely visible at the side from all those different angles. So it's a simple program that looks very nice, I think, just to showcase how we use
those LEDs are incredibly bright, aren't they, at times? Is that defaulting to full brightness, or do you?
It's about half brightness at the moment. So you can vary that with one of the blocks in the extension. You can set the brightness, and I'm going to show that a little bit later with another demo, just with how that works. But yeah, everything is controllable: the color, the brightness, the speed of rotation, if you're going to do that kind of thing, and which LEDs are on and which LEDs are off. It's there's a lot you can program and control with them. That's a really great.
So you've been showing us here, obviously, coding using the block editor. What ones if people wanted to use programming JavaScript? What would the options be there? Python.
So Python has there's online editors for that. Shall I share screen again? I can show you what I'm talking about. So this was the MakeCode editor. If I just open a new, you can inside MakeCode you can switch to JavaScript mode, so you can get a text-based language and a wrapper that is Python as well. If you wanted to program on a different editor, there is the python.microbit.org. So this is another online editor. So again, you're not having to download any programs to make this work. You can type your Python code in here, and you would use we've got some examples on our Kitronik GitHub page for the Halo HD in MicroPython, which I think you can access from the main product page on our website. You can see I've got it here. If you scroll down, and Kevin showed us a bit earlier, we dipped into here a little bit, but if you scroll down further, there are some examples of things you can do. There's a data sheet. It's got all the information about the product, and there's a variety of downloadable example programs that you can get started with, or you can go to our GitHub page. And this is all for MicroPython, so that's on that editor I just showed you. And there's a whole series of code in here and an explanation on the page for how you can control and access all those different parts. So we've made this both MakeCode and MicroPython compatible. So this should be available for everyone who wants to use those different features.
Great. So that was a super simple example of a coding program that you created there. Do we want to talk about any other kind of examples you maybe we have? I mean, you just talked about them there, didn't you? Having some on the page. I don't know if we've got any of those we could show maybe, or.
Yeah, so I've got a couple of things, which I'll switch to the overhead camera so you can see, and I'll hopefully be showing you how it operates as well. So I've got three little ones just to show you, and one of them will show a bit of an online tutorial as well. So this one is a simple clock that you can make, because it's got that real-time clock chip. You can really accurately use it for displaying the time, for setting alarms, for that sort of thing, and it will maintain and keep its time for a very, very long time, beyond our lifetimes. So if I just switch it on, you'll see that initially what we've got is the time ticking around. I set this time earlier. So we've got a second hand ticking around, and we've got a little blue hour hand, and we've got the green minute hand as well. This is probably set for, it's looking quite accurate to the time that we've got, isn't it? This is a really simple little tutorial that we've got some code for online. It comes with the alarm clock kit, or we've got some example programs like I showed you in that list where I linked off to the GitHub page. This is again, is a very simple example, but just shows that clock in use. And you could add things like alarms to this to sound the buzzer when you go off. If you wanted to turn off your buzzer without adding a button, you could do some clapping, for instance, with the microphone, which is the next example I'm just going to show you. I'll flick that off for a minute. Instead, I'll bring in this one. So this was a little clap game that we made. So we've got this zone down here in red, and we've got the blue LED coming around. And the idea with our little game is just that you're supposed to clap when you're inside the red zone. There you go, a little smiley face, hopefully you saw it turned up on the screen, and it gets faster and faster. You've got to make that sound at the right point. Again, it's getting there. It becomes very quick. And it went over. If you clap too early or make too much noise, it goes. But you can see there the microphone input. It's really nice and sensitive, and you can make it listen for one clap, for two claps. Again, that's all nicely controllable. So that really just simply showcases the microphone. And then I'm just going to switch back to showing my screen again. I wanted to show you one of our tutorials that we run with the clock kit. Excuse me just a minute. So this is the alarm clock kit page. This just shows what comes with it. I'm going to just scroll down. And at the bottom here, we've got some links off to some online tutorials, which make it a really good way to do your learning. That's through the MakeCode editor. And I'm just going to show us this wake up light. So rather than using a buzzer, which some of us really don't like, or a big annoying alarm that beeps at us, I'm sure many of you will come across these sunlight emulating alarms, which get gradually brighter and brighter as after the time has been hit. And we thought that would be a great thing to showcase with our alarm clock kit, that you don't have to just use sound. With all those lights on the Halo HD, that's a really great way to have an alarm. So we've made an online tutorial. Now these run through MakeCode, and they give you a really nice step-by-step instructions with some hints and examples to go along. So we've got a little welcome page here just telling you what's going on. There were some other tutorials that took place first, so it gives you some starter code to get going. And then rather than having all the blocks in the whole package, it just gives you the ones that you need for this tutorial. So it's a really good way to get going before you might start out on your own project with this. So you would follow through the code. It would give you some instructions for different things. This is creating some variables, adding some extra code. If you got stuck, you can go here and look at some hints. But the end result would be that you've got an alarm. I've got it here on this microbit. You've got an alarm that when it goes off, it really nicely, gradually gets brighter and brighter. Obviously, I've got lots of lights on, but you can see that the brightness has really increased. And if you had that in your dark room, that would be really nice. You can see just how bright those LEDs are compared with earlier when we had them only on half brightness. Turn them off again.
Wow.
But it's that would be, I think, a much gentler way to wake up in the morning. So it's quite a nice little tutorial that we've got there. And there are several others that come with that alarm clock kit, which make use of all those features you've got on the Halo HD and the microbit, combining them together. And that gives you a really good start for then going and doing your own things, having your own ideas and following some of our other ideas we've got on the website.
Great. Well, thanks for that, Alasdair. I think that's covered, I think, everything we were looking to cover today. I don't know if we've got any questions. Let me just have a check with Mark just to see if there are any. I think we might have covered them all. So no more questions. So, well, also, like I say, thank you, Alasdair. I hope that covers a bit of a whistle-top tour there of the Halo HD, but I think it shows, how many good uses the product does have and how versatile it can be. So by all means, if people do think of questions after today's video, let us know, post them on YouTube, and we'll do our best to answer them for you. But thank you, everyone, and I hope you enjoyed. Oh, we've got one little question here then. So what's in the teacher's pack?
The teacher's pack.
So, I think we're talking about the lesson in a box.
The lesson in a box. I can just talk about that briefly. So it's got, rather than just things like those online tutorials or PDF resources that you can just download from the website, what you'd get with 11 sets of the Halo HD and some other bits with it, some extra bits for some of the lessons, you would then get on a USB drive. We've got subject areas. I'm pretty sure it's geography, physics, computing, and design and technology. And in there are lesson plans, PowerPoints, worksheets, example code, perhaps some CAD files for cutting out some of the materials that are required, and some example setup things. And they're for Key Stage 3 and Key Stage 4. And we've actually written those are actually written and prepared by a teacher who's worked with us on this development, and it's been tried and tested by children in a classroom, just to make sure this is really the right thing that we should be selling and providing for teachers, that it really links in with the curriculum that we've got here in the UK, and we've got some suggested curriculum links for international things as well. So basically it's a full pack. You could just get it out and you could run that lesson without the need for lots of extra planning with it. It's supposed to be ready to go from the box, and you can reuse those again and again because you've got the hardware with it. You've got those resources you can print out and reuse from the USB drive as well. Yeah, so it really is there to make the teacher's life as super simple as it could be. Yeah, and we've got some printouts of things like posters and build ideas and suggestions. So it's a nice visual way as well for the children to learn and engage with. Make it really interesting. Thanks for that, Alasdair. I don't think there are any more questions, so I think we're going to stop it there. But like I said earlier, thanks for your time. Hope everybody's enjoyed viewing this today, and tune in next time we've got another Tech Talk. Thank you. Brilliant. Thanks. Bye, everyone.